Alright, so in this video we're going to look at complex numbers, and this is going to be dealing with imaginary numbers as well. I've already made a few videos about imaginary numbers, so if you need to, I would go check those out. Also, if you like this video or if this is helpful, you can always like or subscribe. So now let's talk about complex numbers. So first of all, complex numbers are essentially a real number like A plus an imaginary number like BI. Okay, so A plus BI is our complex number setup. Okay, so I'll just give you an example. Let's say we have like, I don't know, 3 plus 4i. That would be an example of a complex number. Essentially, it's a real number added or subtracted with an imaginary number. Okay, now we can do a couple different things with these complex numbers. We can add them, we can subtract them, we can multiply, we can divide. So let's look at a couple of those examples. And I'll try to be quick through the first part because most of it at the beginning is pretty straightforward. Like, let's say we have negative 11 plus 3i, and we're adding that with 9 plus 2i. Now, as long as we're adding in between these two parentheses, all we're doing here is combining like terms. So negative 11 plus 9 is negative 2. 3i plus 2i is plus 5i, and there's my answer. All right, so the adding and subtracting is pretty straightforward. Like another example, and you could probably even do this one on your own. Let's say I did 7 minus 2i minus, let's see, I lost my track. There we go. 2 plus 6i. So once again, when we're doing this, we're just combining like terms. So 7 minus 2 would be 5. And then we would do negative 2i minus 6i, which would be minus 8i. So there would be my answer. All right, so now let's look at multiplying. Now, before we multiply, just keep this in mind. If you end up with I squared, remember that can be replaced with negative 1. So let's say I were to multiply, let's just say 2i times 8 minus 3i. All right, if we were to multiply this, we're just going to distribute. We're going to say 2i times 8 is 16i minus 2 times 3 is 6, I times I is I squared, and then we can take the extra step of replacing this I squared with negative 1. So we can say 16i minus 6 times negative 1, which is just going to give us plus 6. And there would be my answer. You could also rewrite it like this, which is probably how you would see it rewritten, 16 or 6 plus 16i, but it's all the same. Let's look at another example of the multiplying just so we can get an idea. 7 plus I times 4 minus I. Now, when we're multiplying these two parentheses, we're actually multiplying two binomials, which means we need to FOIL. Or we're essentially distributing twice. We're going to take 7 and distribute that to 4 and negative I. So that would give me 28 minus 7i. Then we're going to take I, and we're going to distribute that to 4 and negative I. So that would give me plus 4i minus I squared. And once again, we can go ahead and replace I squared with negative 1. So then we would end up with 28 minus 7i plus 4i minus a negative 1, which actually changes to plus 1. So now all we have to do is combine like terms. 28 plus 1 would give me 29. Negative 7i plus 4i is going to be negative 3i, and we're finished. All right, so everything thus far has been pretty straightforward. Now, you've probably seen this if you've done radicals at all. You've seen this, but we need to look at something called a complex conjugate. Now, a complex conjugate is going to be used for dividing. Okay, so we're not doing this just to do it. There's a purpose behind it. So a complex conjugate is basically this. If I have like 8 plus I, the complex conjugate of that is just taking this minus sign and making it, or taking this plus sign and making it a minus sign. Like, try this one. 2 plus 3i. What's the complex conjugate of that? It would be 2 minus 3i. So once again, if you've done radicals at all, you've already heard what a conjugate is. But if you haven't, it's literally just flipping the sign. Now, here's why we need that. Because when we're dividing, and this is the last part of complex numbers that we need to touch on, there's two cases that you can have. You can have a case like this, 10 over 2i. You can also have a case like this, where it's like negative 2 over 5 minus I. Now, in these examples, here's the issue. We don't want to leave that on the bottom of a fraction, because technically, remember, I is a radical. It's the square root of negative 1. So I'm not really supposed to leave radicals on the bottom. Now, as you go through math, depending on your teacher, depending on the class, sometimes it'll be allowed, sometimes it won't. So we need to look at it just in case it's not allowed to leave I in the bottom. So what we have to do here is we have to rationalize this. So if you just have one term on the bottom, you can rationalize this by multiplying by I on the top and the bottom. So like for this example, we would say 10i over 2i squared. Now, 2i squared, we can replace this I squared with negative 1. And now you can see that we're going to end up with 10i on the top and negative 2 on the bottom. So then that gives me negative 5i. So now I'm finished. So if there's just an example where there's one term on the bottom, we can just multiply by I to get rid of it. Now, let's do another one of those and then we'll talk about this example, just so you can see. So once again, if we're dividing by I, let's say I have 4 over negative 9. Or actually, let's make it a little bit harder. Let's say we do negative 8 minus 2i all over 6i. All right, so once again, you can see we're dividing and we have I on the bottom. So we don't want to keep it there, but we only have one term on the bottom. So that means the easy fix is to just multiply by I on the top and the bottom. So that's going to give me I times negative 8 minus 2i all over 6i squared. And now you can see from here, we're going to replace I squared with negative 1. So that's going to give me a negative 6 on the bottom. And on the top, we're actually going to end up with negative 8i minus, negative 8i minus 2i squared. And now we have another situation where we can replace I squared with negative 1. So it would become negative 8i, that would become plus 2 over negative 6. So now the last thing we have to do is just rewrite our answer. So typically what you'll see is the fraction broken apart like this, 2 over negative 6, because this is one single denominator, so we can actually break this into two separate fractions, minus 8i over negative 6. So, and actually I would probably write it like this, honestly. I would probably write it where I would say plus negative, no, we could do it like this. We could say minus 8i over negative 6. Yeah, that fits better. All right. So now what we can end up doing is we can say 2 over negative 6 is going to give me 1 over negative 3 minus 8 over negative 6 is going to give me 4i over negative 3. So now I can rewrite that all together. I can say 1 minus 4i over negative 3. And that would be my final answer. All right, so now let's look at a conjugate example. So let's say, once again, let's go back to this one. Negative 2 over 5 minus I. Now, once again, we are dividing with I on the bottom, but we no longer have one single term. This is actually two terms now. It's a complex number. All right, so if we have a complex number, we have to multiply on the top and bottom by the complex conjugate, which is once again just taking this minus sign and making it a plus sign. So now we're multiplying all of this. Now, what that will end up giving me is negative 2 times 5 plus I On the bottom, if I say 5 times 5, that gives me 25. 5 times I would give me plus 5i. Negative I times negative, or positive 5 would give me negative 5i. And then negative I times I would give me minus I squared. So now you can see what this leaves me with. It leaves me with 25 minus I squared. And now I have another opportunity to take I squared and replace it with negative 1. So I can say negative 10, because I'm distributing negative 2 to 5 and to I could say negative 10 minus 2i all over, this would give me, let's see, that would become 25 plus 1, so that would give me 26. And now this one's a little bit harder to break down, but let's just see if we could break it down. Let's see, negative 10 over 26, that would give me, all right, that would give me 5 over 13, negative 5 over 13, minus 2 over 26 would give me I over 13, because it would just be 1 over 13. So then this would give me negative 5 minus I over 13. And that would be my answer. So now once again, when we have a binomial on the bottom, we're going to multiply by the complex conjugate to get rid of it. When we are multiplying just a monomial on the bottom, or a single term, we're going to multiply just by I to get rid of it. Let's look at one more just so you can see it. Let's say we have, we'll make this a little bit harder. 7 plus 3i all over 2 plus I. Now, once again, we know we can't leave I on the bottom because technically it's a radical, but then we have to just double check. Do I have one term on the bottom, or two terms? And I have two terms, which means I'm going to multiply by the complex conjugate. So 2 minus I, 2 minus I on the top and the bottom. And now you're going to see we have to FOIL on the top and the bottom, and this is the hardest example. So on the top, we're going to have 7 plus 3i times 2 minus I. We'll worry about that in a second. Now, the bottom's a little bit easier to break down because it's going to give me 4. Let's see, when I FOIL this, it gives me 4 minus, it would give me minus 2i plus 2i minus I squared. So 4 minus I squared, since these two are going to cancel. All right, so now let's do some FOILing on the top. So on the top, we're going to say 7 minus 2, which is 14. 7 minus, or 7 times negative I, which is minus 7i. Then we're going to do 3i times 2, which is plus 6i. And then 3i minus, or times negative I. So it would be minus 3i squared. All over. Now, right here, you can see on the bottom, we're going to be able to replace this negative I, or I squared, with negative 1. So it would give me, let's see, 4 plus 1. So this is going to give me 5 on the bottom. Now, on the top, let's see, we just need to combine our like terms. We can also do this. This negative I, this I squared is negative 1. So I can actually replace that before I do this. I can say 14 minus 7i plus 6i plus 3. Because if this is negative 1, that's going to make this a negative 3, and minus a negative equals a positive. So over 5. So now we just combine our like terms. 14 plus 3 is 17. Negative 7i plus 6i is minus I, and it's all over 5. All right, now, these examples at the end were a little bit harder, but I tried to go through them quickly. If you need to brushing up on like your FOILing or multiplying like that, I would suggest you do that. But remember, the biggest takeaway with the dividing is if you have two terms on the bottom, you have to multiply by the complex conjugate. If there's only one term on the bottom, you just multiply by I.